we have done the inverse function for sine, and this lecture will continue on inverse function of cosine and tangent. Recall, sine function is not a one-to-one, so when we restrict our domain from negative pi over 2 to the positive pi over 2, then we get one-to-one function. Okay, so we started from there. That's basically the angles were from quadrant 4 to 1. Okay. Now, cosine. Again, similar to sine, cosine started from 1 and then goes to negative pi, from 1 to goes to negative 1 and then goes to the positive 1. So you know sine is different, initiated like this. That was sine. Okay, sine like that. Cosine started with 1, sine started with 0. And then again for the horizontal line test, you have more than one intersections with the picture, so cosine is not a one-to-one like sine x. In order to study the inverse function, we need a function to be one-to-one. So we then restrict our domain from 0 to pi. Okay, from 0 to pi, then you get one-to-one. You see the intersection. There is only one intersection when you restrict the picture to here. So the domain, remember, is from 0 to pi. And the range is from negative 1 to positive 1. Like this. The inverse will be different now. Okay. So if we restrict our angle from 0 to pi, that's from angle quadrant 1 to quadrant 4. Okay, so let's look at our definition. You know, cosine, how was cosine defined? Cosine was the coordinate of all those boundary points on the unit circle. Okay, that was how cosine defined. That's probably the first couple of lectures in the trigonometric function. So this is very basic part now. Okay, so here probably I can write some basic things down here. Cosine pi over 6 is radical 3 over 2. X coordinate. So today is about x coordinate. For sine, they are all y coordinate. Cosine, probably I want to write here. Cosine pi over 4 is radical 2 over 2 x. Cosine pi over 3 is 1/2. Again, that's x. Okay. Cosine, this angle, how big? Pi over 2 is 0. Okay, again, x coordinate. I did all the values for angle from like in the quadrant 1. You may do the rest of them. I don't want to repeat. Yeah, like a cosine 2 pi over 3 is negative 1/2. Okay, because it's on the left hand side now, x will be negative. So when angle ranges from 0 to pi, the x coordinates from this side switch to the left. So you then have a negative values for cosine. Okay, when you look at all the x's, they're negative. All right. Now, we are working on the cosine. So you then may also write let me put the things down here. You see, this is what we get. Cosine pi over 6 is radical 3 over 2. That's this one. Okay. And cosine 0 is 1, you see. Cosine 0, oh, right here. Cosine 0. 0 degrees. I didn't write that. So cosine 0, this 0 is 1. Okay. Now, cosine 0 is 1. Cosine pi over 2 is 0. Pi over 2 is 0. Cosine. And cosine 2 pi over 3. 2 pi over 3. That's the one right here, 2 pi over 3. Is negative 1/2 x coordinate. Okay. 3 pi over 4, this angle, and then you have x coordinate is negative 2 pi over negative radical 2 over 2. You can do this angle yourself. But for cosine pi, you have negative 1. That's the one right here. Cosine this angle is x coordinate, negative 1. This is what we had at the very beginning about cosine. Okay? So actually, starting with the very beginning gives us very good information. This is from angles. From angles to the trigonometric values, to the values of trigonometric functions, cosine. So, angles to values. Like sine, then we have a like sine x has arcsine, and here we have arccosine. Arccosine is from the values to the angles. Remember, we restricted our domain from 0 to pi. So when you get the values from values to angles, all those values must be from 0 to pi. It is easy to say, then you actually do it. Okay? So for arccosine, the output is from 0 to pi. Because when we take our input is from 0 to pi, we get positive value and negative values. And for the positive negative values of trigonometric functions, when you go back for cosine, you always get from 0 to 2 pi. That means no negative for arccosine. That's very important thing. Don't write arccosine, you have a negative value. Cosine can have a negative values, and arccosine you always get positive, but cannot be greater than pi. Okay? So it's basically you write in this way. cosine radical 3 over 2, you then have the angle. Arc cosine 1, you then have a 0. Okay? And then arc cosine 0, you then have a pi over 2. And then arc cosine negative 1/2, you then have a 2 pi over 3. So that cases for those two. But you can see clearly negative 1/2, you got 2 pi over 3, that's positive. It cannot be negative. No negative outputs for arc cosine. Okay, and here cosine, arc cosine negative 1, you get pi. Okay, yeah. So these values are from the union circle. All right, and then you see negative cosine, arc cosine negative 1 is pi. That's right here. Okay, so here there are a couple of things I want to emphasize. The first one is the graph. Look, we restricted our domain from 0 to pi, so we get cosine. This is the graph for cosine. Now, how did we get arc cosine? Previously, you know, if this is the line for y equals x, you flip this one based on y equals x, then this point goes to here, 1, 0, 1 goes to 1, 0. This point. That's the starting point for arc cosine. Okay? And then this point, x-intercept for cosine x, if you flip based on that, it goes to pi over 2, 0 goes to 0 pi over 2. And then pi negative 1, this point, flip, then it goes negative 1 pi. Again, arc cosine, all the values are above x-axis. So the output is positive. Okay? And the input can be from negative 1 to positive 1. So, the range 0 pi, 0 pi. No negative. So arc cosine x all are greater than 0. Okay? Domain from negative 1 to positive 1. Yeah, this is from the point of view is that the inverse function is symmetric with respect to cosine x. Those two are symmetric. Arc cosine and cosine are symmetric.